flies and what are the requirements it has. Then we will have a look at the flow analysis of a bullet, and we probably have some animations to look at to understand it much in depth. Okay. So basically, when an object moves through air, forces are generated by the motion between the air and surface of the body, and these forces, will categorize how a bullet will behave, or how any object that is moving through an air or through air will behave based on the behavior of the flow, like based on its sheer speed, velocity, whatever we call it. It is divided into three sections: subsonic, so sonic, and supersonic. In the last session, I might add, it's a continuation. This session is a continuation of the previous session that we had in the last week itself. It was about the subsonic flights of the commercial jets, where we talked about Boeing 787, and it was kept in the subsonic region. Okay, so the basic difference for those who don't know, it's like subsonic is basically you are moving at a lesser speed than the speed of sound. Sonic means you are moving with the speed equal to the speed of sound. Supersonic means you are going above the speed of sound. Okay, you're going at a speed above the speed of sound. That's the basic and very generic description. But what goes into in depth, like how do you classify a flow being subsonic, sonic, or supersonic, right? So we have Mach number for that. Basically, when we talk about Mach number is essentially your velocity of the flow at which you are moving divided by the sonic velocity. And if you are moving at a speed of speed less than the sonic velocity, your flow will be classified as subsonic. If you are moving at equal velocity, it will be classified as transonic or sonic, and again it will be moved as a supersonic. So that's the general context we have for taking Mach number into account of things. Okay, so we'll talk about more of how it is impacted and how the flow is. So basically, when you talk about flows, right? So you will have, when you talk about flows for any kind of a movement based on Mach number, the flow evaluation is basically carried out. And with each stage you are going to move in, you are going to move at a better speed. So basically, this also we have discussed in the last session. Basically, when we talk about Mach number, when we talk about objects flying in a certain region, you have to fly in a certain region in order to make your flight stable. Okay, it may be a bullet, it may be an airplane, it may be anything that is moving in air at higher speeds. So basically, to talk about that, we just give you guys a reference. Okay, so when we talk about the flight, right, the thing that I was mentioning, you will, when you are moving at a speed, which is basically when your bullet, just a minute, just use, just a minute. I will. Consider this is your bullet, okay? So I'm not proficient in drawing, so it's just like you can understand. Okay? So let's say this bullet is moving in air. It is moving below the Mach number, at a velocity below the, which is classified as below the Mach number. And that with that velocity, if it's there, your flow becomes stable. When it tries to move from subsonic region to transonic region, basically your transonic region is classified between 0.8 of Mach number to 1.2. So this is the exact period through which any object would go into transition phase. That is, from a subsonic state, the speed changes from subsonic to supersonic, and this region becomes highly unstable due to the exact reason, because it isn't transitioning, speed is increasing. And once your flow becomes greater than Mach number 1, you will have a sonic boom. You will have a kind of a transition, like instant flow change or flow regime change, So this actually what I'm talking about, it happens at a very faster rate. So if you watch it in a slow motion, if you think it in a slow motion, you will have like a, so whatever I'm talking about is going to be very instant. So in an instant, it will have like a kind of a shock wave generating or a sonic boom generating when the phase changes. And your flow will be more dynamic in that range, okay? More dynamic due to that. So due to that itself, what will happen is when you are moving at higher speeds, like due to that, the shock waves are going to generate. And let me tell you, when you are talking about subsonic region, it is going to have this impact. Okay, so it is your bullet will be, or your any object will be in this very stable condition. It is moving at a constant pace. It will have steady kind of a flow. But when it moves into the transonic state, due to the transitioning phase, there is a lot of changes that are happening in the in the fluid itself at a fundamental level, because there are higher pressures involved. There are a lot of elements involved. Like due to that phase itself, your temperature and your velocity will also change. Your pressure will also becomes high. This is the pressure that is being exerted on the surface of the bullet. Due to that exertion, the overall, if you maintain the flight between this region from 0.8 to 1.2 Mach number region, the flight becomes very unstable, and there is like kind of a turbulence happening. So if I show you over here, what will happen basically is, due to this higher speeds at this stage, you will generate kind of a pressure barrier. So when you are moving from subsonic to supersonic, basically the fluid continuum, you need to know about the fluid continuum part at this stage. Okay, so when you have these flow molecules, let's suppose these are my flow molecules. Okay, they are traveling in this direction, like nothing is happening. It's like they are chilling. Okay, and when their speed is increasing from Mach number 0.8 to 0.9, let's say. Okay, they usually, this flow regime is assumed as a continuum. Usually any flow regime is assumed as a continuum. That means your fluid is a continuous form. It is going to get deformed under the action of any external forces or surrounding forces. Okay, and when the fluid particles are moving, they actually are moving in a very streamlined manner due to the due to the guidance of the force that is being applied upon. Okay, so there are multiple forces applying. So there is a one resultant force that will guide the fluid particles in certain way. So I'm talking about air in this regime, for instances. Okay, so this guided or streamlined flow, it is also called as a streamlined flow, by the way. Now this guided flow, what will happen is once your fluid regime tries to shift or it tries to move in the transonic region, there is less time in order to understand for the fluid particle that is back at the end over here. For this fluid particle, it is lesser, it is lesser, it doesn't have that much amount of time to understand what is happening over here. So if there is an obstacle ahead and these fluid particles are moving, normally they will have kind of a understanding. And yeah, so the front particles are shifting, due to which the continuous particles that are following up the frontal particles will also change their flow, change their regime according to the streamline that is being formed at a slower speed. Okay, but this transition is due to the slower speed. It gives the time. It gives these particles enough time to adjust to the frontal obstacles. But when you talk about higher speeds like transonic, supersonic speeds, there's not enough time, and you cannot, like, these fluid particles cannot anticipate what is coming in front of them, due to which they kind of gather together. Like basically, they will form a barrier before moving into the transonic state. Like while going into the transonic state, from there going into the supersonic state, it will form a barrier kind of around the surface, which is basically invisible barrier we cannot see, but it is there. This barrier is formed due to immense pressure that the particles are facing due to sudden, due to the the most amount of pressure that is being acted upon, and because when you are moving in air or any object that is moving in air, let's suppose we take this object that is moving in air, it tries to kind of compress the fluid that is immediately in front of it. If it's moving in air, so let's suppose, so it tries to compress the air that is directly in front of it, that is directly in front of it. So when it tries to move at a higher speed at a supersonic range. This phenomena would cause to rise in pressure, and the air that is going to move up behind this, it will also form the same way because there is a higher amount of drag. There will be like a barrier kind of stuff form, and this barrier due to the speeds are being higher, due to this phenomena is moving at is happening very fast. The transition happens very fast from subsonic to supersonic. We cannot maintain the flight in the transonic region. I'll tell you about that, why it is not being maintained. But when you talk about the transition from subsonic to supersonic, this is why we have the sonic boom. Basically, we have this loud shock wave that is being generated when an object tries to get passed from subsonic region to supersonic region. And to talk about this, basically, you will have this kind of a shock wave generating over the object. And behind that object, basically, you will have a higher amount of turbulence being generated. Now, what you're seeing over here are the images of kind of air condensing over the surface. So these are like similar to these. These are not exactly the sound barriers that we talk about or the shock wave phenomena that I'm talking about. But physically or according to physics, this is how it would look like in a flow regime. This is how the overall like structure of a sound wave barrier will look like, because this is not a sound wave barrier. This is just due to the higher pressure and temperatures that of the air that is moving past this object, and it depends on the humidification of the atmosphere as well, of the air as well. So when your aircraft or when your bullet is trying to move past through a fluid that has higher humidity, through air that has higher humidity, there like water condensation happens. The basically generation of cloud happens, and due to that, like this is just because of the pressure and the temperature differences, and due to the different air differences, you will have this barrier generated. It's not a shock wave. I'm just mentioning this because to show you how it would look like if you were to visualize it. So this is exactly why we cannot have our flow into the transonic region, because when you have a shock wave generating, okay, when you are in a supersonic flow, the shock wave will get stabilized, because it will your object will have a steady flow. It will have a certain amount of velocity in the supersonic region as well. The shock wave will be there, and it is kind of stable because it is moving at a faster rate. But when you are shifting, when you are transitioning, when your speed gets changed, the shock waves that I'm talking about that are going to be generated above and below the structure or the bullet, they they tend to change their location, and due to that, any of your object would try to oscillate in midair, and due to that oscillation, because of the turbulence, because of the higher pressure and change in pressure, sudden change in pressures that is going to occur. Due to that, basically what happens is you cannot maintain the stability of the bullet or even of the aircraft or whatever you're talking about. So due to that, you need to avoid the transonic state. So that's why when you're anybody's flying the commercial planes, it will be in the terms of like it will be in either in subsonic region or it will be in supersonic region, supersonic jets that are flying in, right? So there is not much advancements that has been done, or basically it's very difficult to conceive supersonic flight regime or attain a supersonic flight regime, because it is difficult to get there if with a larger object. So if you are talking about a larger object like an aircraft, it is harder for that kind of aircraft or larger object to get to supersonic region. From subsonic to supersonic region, it requires very high advanced technology and like very much accurate precision in order to achieve that flight. That's why the jets that are capable of supersonic flights have like basically are more expensive or not feasible for any of your general operations. And similar concept is with the bullet. So when you are trying to fire a bullet from any gun, like from let's take snipers for example. So when you're trying to fire a bullet from a sniper, this the bullet trajectory or the bullet speed is maintained in such a way that it attains supersonic flight, it maintains supersonic flight till it reaches its point of impact, which is basically it has an established range defined for each and every gun. There is a established kind of range meter. So the maximum a sniper can go to is around 1,000 yards. That means like around I think it's around 1,000 meters. So it's similar to like 950 or 970 something meters. That's the maximum bullet can travel. So that's the maximum range of, even for Kar98 it is. So that's the general idea and that's the general physics behind this. Okay. So we have talked about this. Now let me show you how it actually affects. So basically, when you talk about bullet being fired, okay, I'll just draw a bullet over here, and if it's moving in this direction in supersonic region, of course, for example, let's take a, let me just place it over here. Yeah. Okay. So this is the bullet. Okay. If I try to maintain this bullet in transonic region, the shock waves that are generating at any of this stage will try to move across this surface. Like if let's suppose this is the shock wave that is being generated. So due to the change in velocity, the pressure at the rate which the pressure are changing, because you are speeding up at a very higher rate. Due to that, your pressure is going to also change at a very higher rate, and this actually affects your flow. Basically, when if the pressure at the top side of the bullet becomes higher than as compared to the pressure that is being applied over here at the below region, it is trying to it will try to oscillate, or it will try to move in region. So it will also, it's not only in vertical and horizontal direction, like not only at the top and the bottom, it will also change towards the front and rear end of the bullet itself. So sometimes what will happen is sometimes what will happen is your shock waves can, so due to which what will happen is your aircraft will try to oscillate in this region in this manner. So it will kind of aircraft or even bullet try to oscillate, and due to that oscillated motion, the trajectory that you are aiming for is missed. And this is the biggest impact, or this is the biggest reason why we don't operate in transonic state. Okay, so now when we talk about flow around the bullet, right? So let's have a demonstration, okay, how your velocity field would look like. But before we go into this, I just want to ask if anybody has any questions. You can drop them in the chat box, or you can even ask me. So if anybody has any difficulties understanding what I've just spoke about, or if you want me to re-explain things, then I'll be able to just yeah. If you can unmute yourself and you can ask the doubts. Yeah. Does anybody have any doubt? So what about left and right side? Shiva says, can you explain, Shiva, what you are asking? Left and right side. Or you hello? Yeah. So when you're moving in this direction, like if your bullet is moving in this direction, so it doesn't matter what happens left and right. If it only matters when you take in consideration of wind flow. Okay. So if your wind is moving or blowing over the bullet's trajectory, if it's going in this direction, let's suppose, and if your wind is moving in this direction, then it will try to push the bullet in that direction. So that those effects are also there if you're asking about that. But in general, when your bullet is moving in line of the flow, the kind of airflow that is being generated over the pressure that is being generated. So it's kind of like it will try to oscillate also. It will try to pitch also. So depends when you are operating in the transonic state. That's why we mostly don't operate in transonic state. Yeah. How does pressure on bullet vary? Why does it oscillate? Basically, when you talk about varying pressure, it only occurs in transonic state. Okay, so take this as an example. Okay. If I'm talking about flow variation, right? For a bullet, due to rising speed, meaning when you are in transonic state, your speed is not constant. First of all, it is varying, it is changing, and due to that change of speed, your pressure keeps changing. So when this flow dynamic depends on the Bernoulli's principle of flow. When your velocity is higher, technically your pressure is lower, but you are moving at a speed which is equivalent to speed of sound. Due to that higher amount of speed, the laws of physics kind of change basically. So when you are operating at that flow, the pressure that the air wave is generating becomes higher. The molecules that are at this stage, for example, will feel more pressure as compared to the molecules that are here or that are over here. So this is like a building up. So due to that. So this is a very complicated dynamic to understand. So due to that, it's kind of it's kind of heavy. And also, if my sonic barrier or if the shockwave barrier is generated in a different, like it's kind of an oscillating manner because of the because you are trying to maintain or you're trying to flow through the transitioning stage. You are trying to move at that speed. So yeah, that's the general idea. Sagar says, if you want to recreate the flow of a bullet in Ansys CFD, then please explain the boundary conditions for that. Okay. So yeah, I'll talk about that. Thiru, yeah, I'll share the Google form towards the end of the session. Till then, we can talk about it. I guess I'll talk about the Ansys analysis and stuff over there while I'm talking about the flow dynamic. Okay. So right now we have just seen about the like how it will look like. We are just assuming that this is how. So I'm just basically telling you that through drawings that this is how it is going to be. So let's just have a look at a fluid analysis, okay, of Ansys, for example. I'll talk about it, how it is done, etc. But let's just have a look at it, how the velocity is changing and how the overall fluid behaves around the bullet. So when your bullet is launched from the barrel, this is how your velocity, this is how the air behaves in terms of velocity. And due to this, like as you can see over here, there is this barrier generated. There are these layers of fluid that you are seeing. These are velocity layers. Basically, the particles at this stage are moving at a certain speed and a certain way. Due to that, these kind of barriers are generated. And this is still in transitioning, by the way. So never mind. So when you are moving, you can notice over here, there is a velocity barrier, as you can see, is generated at the top side and the bottom side. So as you speed up, this barrier gets generated. And when you move into supersonic region and moving at a stable speed in that supersonic region, you're like around 900 kilometers per hour. That level of speed, that is kind of a supersonic speed. So there, the sound barrier is kind of like the shockwave or the barrier that is generated is constant. So this is a pressure graph, or this is how pressure behaves. So this yellow part that you are seeing, or the red part, are the color codings. So basically, your pressure is highest over here, and the red means highest, blue means the lowest. So this color coding it might be different from the video, but that's how the general color coding in Ansys or in any of the CFD softwares related to that are being made. So when this is how your pressure is going to generate or move when you are moving in this region, and where you have the white part, okay, so that's basically vacuum. There is no pressure over there. So these are the also advantages of this color coding to understand different behavior at different stages, locations using Ansys. Now we look at a temperature field. So it's just like same thing. The color coding is kind of different in this video. Now let's look at the shock waves. Okay, what I'm talking about exactly. So here you will be able to exactly see how the shock waves are generated. So now once it's launched, this is how the shock waves are generated. All the pattern for the flow behavior is kind of similar. It is kind of similar, very different in nature. So as you can see over here, at this stage itself, these are the sound barriers or the shockwave barriers that are being generated. This is there at the speed which the bullet is moving in the supersonic region, and this is what I'm talking about, that the shockwaves are basically generated over the surface. But if you're transitioning, if you're trying to move in the transonics range from 0.8 to 1.2, in that region, these becomes unstable. Okay. So talk more about this. Actually, I have a video for you. So to show you about how it is basically generated. Okay. So this is how you are going to lodge a bullet, and then this is firing pin. It will ignite the primer, and then due to this consume the power powder will ignite. It will give the thrust necessary for the bullet to move. Also, the insides of the barrels are kind of have this spiral kind of way where it tries to revolve the bullet. Okay, so due to that revolving, the bullet is also gaining momentum along with the speed. Okay, due to these sections, the bullet is gaining momentum along with speeds, and due to that inertia, it will also have higher speeds. So that sort of like a combined effect is being generated due to the linear and the rotationary motion of the bullet. Is achieved. This is basically achieved to. It's basically done to achieve 1,000 meter range for a bullet. Okay. And when you talk about its flight, right? So when you talk about its flight, beyond 1,000 yards, it kind of loses its speed slowly due to the drag, due to the higher speed, and it tries to lose the trajectory. It is moving in, and eventually it falls off. So when you are making sure that you want to hit a target at a certain specific range, you need to make sure that the speed of the bullet, basically the speed of this bullet, is at a certain stage, basically in supersonic region, so that it can maintain its trajectory against the resistance. So that's the general concept, and that's the general idea about the bullet flight. So similar idea is there when we talk about Kar98. Basically, Kar98 is also called as Kar98 Groups. It's originated from Germany at the times of World War II. So it's kind of made highly efficient nowadays. It's very useful. It's very like efficient in terms of accuracy, in terms of range. Just that when you are operating with a Kar98, right? So you need to have your trajectory. So if you talk about a trajectory, right? I'll just show you how it is maintained. So you will have, let's suppose this is your crosshair or scope to which you have to visualize. Okay, this is the bullet path. Okay, and to meet this, basically this is your sniper barrel where your bullet is going to get launched. Okay, you need to have, as you are aiming from this, your aim or your target will be at this location. So you need to hit this particular point. Okay, and to reach this kind of dynamic, actually you actually need to have kind of tilted barrel through which the bullet will be fired. It will move in this direction. It will attain a projectile. It will go in this way, and it will hit the target in this manner. So this actually is what is done while actually trying to fire a bullet. So you must have seen in movies as well. There is a stand that comes below any kind of a sniper rifle. So it is to make sure that bullet is following a proper trajectory. It's not like what I'm showing you here is a very rough idea of the dynamic that I'm speaking about. So it will be much more clearer in the same video that I'm talking about. So this stand is what I'm talking about. So as you can see also, the alignment of the sniper rifle over here is mentioned is slightly tilted, is not perfectly horizontal. It is done to meet the crosshair distance, because what you are seeing is from the crosshair. What you need to, when you are aiming from the crosshair, you have this trajectory, this in the line of the crosshair. that is you need to maintain basically for the bullet to fly, and accordingly you need to adjust the your alignment of the equipment, and this how it is maintained. This is why this stand is there in order for you to give it support, in order for you to give it better dynamic for the projectile to be able to fly. So this is the another thing about the Kar98. So that's the general idea about the topic that I was referring to. So if anybody has any questions about that, I'll talk about that. So yeah, Sagar, let me address this Ansys CFD, how you can explain the boundary conditions. Okay. So if you are trying to solve, okay. So if you are trying to solve it for just a minute. Yeah. So if you are trying to solve it for Ansys or for bullet speed, you need to keep in mind that the velocity that you are trying to take is going to be in like around 900 or 800, 900 kilometers per hour. In that range, your velocity would be. You will have first off, you'll be setting up a domain in which the bullet dynamic or the bullet will try to move in that region, and you will give inlet velocity to the inlet itself, and you will calibrate pressure at the outlet. So it's very simple, just that the velocity would be higher. You also need to make sure that the bullet intensity ratio that you're going to maintain. So it's usually 5/10. So you can basically it is turbulent intensity is 5. It's kept as 5, and I think the dissipation is kept at 10, so that you can probably reduce to 1 and 10 or 1 and 7. So accordingly you can have. That's pretty much it about the explanation. If you need anything more sort, then yeah, you can ask me. Yeah, Akash, you were trying to say something. Anybody has any question, they can unmute themselves and talk. It's not a problem. I see a lot of people raise their hands. So Shiva said, does the oscillation depends on the center of mass of a bullet? No, no, no. The oscillation happens when you're in transitions phase. Okay, so when you're in transonic phase, you imagine the bullet is moving at speed equivalent to the speed of sound. Okay, at that speeds only this will occur. Normal speed this won't occur, and the oscillation is induced due to the shock waves and due to the instability of the shock waves that are being generated over the surface. So normally, when you talk about shock waves, right, you will have this constant phase. Just a minute. So when you are talking about higher speeds, you will have the shock waves that are constant. But when you are trying to maintain your flight in transonic region, the shock waves itself are generating randomly. So basically, they try to move across the surface. If you're looking at it horizontally, the upper shock wave is the upper shock wave and the lower shock wave would it's kind of call it as. Sorry. So yeah, what I was mentioning was like due to the due to the fire pin connecting the primer, it starts ignition, and that's why the bullet moves in forward direction. What does Kar98 stand for? So Kar98 is basically Carbinar or is Carabiner, and I'm not sure. Carabiner 98 Cruise. It's a name given by I think German people at the times of World War II, and it's a bolt action rifle. It's not a. It's kind of a. There is a lot of comparison that goes on with snipers and Kar98, and Kar98 not being a sniper. It's actually true. Kar98 is not a sniper rifle. It's a bolt action rifle, but it gives better accuracy. It gives better results uh, due to its configuration itself, and it's comparable to sniper. So yeah. So I hope everybody has. I hope I have answered all of your questions. Does lift and drag occurs in a bullet? Yes, yes, definitely. So when your airflow is due to the airflow itself, due to the drag itself, uh, after a certain time, your bullet will try to slow down, and due to which you will have a certain predefined range for the bullet. Okay, and due to that itself, like that's why I said, like you can reach a bullet 1,000 meters. That means you can reach, you can take the bullet to when you fire it, it will reach 1,000 meters at the supersonic speed that it has. And after that, it will lose its projectile, it will lose its stability, and it will fall down basically. What is the purpose or advantage of giving trajectory rather than horizontal motion? Because um, just a minute. Yeah. Because when you are moving in a trajectory, so it's not like if you give it horizontal motion, okay, so you need to have this scope at sideways. So basically, uh, so this is your crosshair from which you are going to look at the target. This is the barrel to which the bullet is going to flow. Bullet is going to get fired. Now, you can do that basically if you want to go into the horizontal motion. You can actually have it like sideways, but it is highly impractical to have the crosshair sideways. It will also, you can never have, because if you put it sideways, then you need to tilt the barrel sideways in order to match for the mark that you are trying to hit, and due to which basically as you are tilting the sorry so as you are tilting the barrier, right, if you tilt it too much, it will again go in this direction. It will take a longer time for it to have a projectile. That's why basically you have to match up with the target mark. If your target is over here, if your bullet or the sniper rifle is in horizontal direction, is pointing this direction, so the point will come over here. So if your bullet tries to move in horizontal direction, it will hit this point instead of the target you are actually planned for. So that's why you have to have a kind of a projectile in order to hit that mark accordingly. So yeah. What are the different ways for increasing range of bullet in different gun types? So there are a couple of ways. Basically, you can introduce the slots that I was mentioning about to actually increase the oscillation, or not oscillation actually, to increase the rotary motion of the bullet. That will give the bullet a momentum while it is gaining speed. So it will gain speed faster, have a better range altogether. This is one kind of way to do it. The best way to do it is basically calibrate the bullet surface. So make the surface highly aerodynamic as possible. There comes stability of flight. There comes like a lot of parameters that can be done. But these are the two prime reasons which we could work on in order to increase the like in order to basically reduce the drag and get the bullet more range. What is the effective range of Kar98 Sniper Bullet? So the effective range is kind of, so if you are going with a no scope or basically iron sight, which doesn't have any magnifying situation, based on your judging, based on the judging of the projectile that you are going to launch with, it will achieve around 500 meters of accurate operation. So within the 500 meters of distance, you will be able to hit the mark with pretty much great accuracy. If you are having a better scope, like telescopic, they are also called telescopic sights. So they will magnify the distance you are looking at. It will also give you, it will also have give you a better boost in judging the projectile action, and also in that case itself, we will have a better range. So it can go up to 1,000 meters. So yeah, that's about it. What are the points to consider while shooting Kar98? Okay. So basically, you need to consider, like, if you're shooting in real time, then you need to consider the first and foremost how the wind is, how the atmosphere is, basically how it is moving. Uh, if it is horizontal, you actually need to point in slightly sideways so that your bullet will again try to move in this direction, or it will again go in this direction. So it will basically have a combined reaction of that. It will try to move and go hit the target at that. So all these things are there when you are taking into consideration. There is air density. There is so these are the points are considered while designing bullet or testing it against different regimes, different atmospheres. But while shooting, you all need to have a like kind of a judgment. You need to have a stability while shooting. You need to have better scope. If you are firing for long range, if you are firing for short range, then iron sights would do. So all these points are like considered while firing a bullet. But while designing it, it's a pretty tight process. Basically, aerodynamics is the one thing that is worked upon, considering the projectile thing, and in terms of giving it the thrust, giving the optimum boost. Then there comes the combustion part of it, the insides of the caliber. So yeah. Is it possible to fire a gun without gunpowder? I'm not sure. I haven't done a research on this, but yeah, there might be a way due to different compounds and their reaction, how they kind of generate thrust. So it depends. At the moment, I am not sure. I'll check it out and I'll get back to you in the next session, if it's possible. So, yeah. So how the trajectory angle is decided and how to identify it. Okay. So sometimes you have like a okay. Sometimes you have a judgment, basically by with enough practice, with enough understanding of how it is moving, you will have a general idea. But there are advanced technologies, advanced scopes who provide kind of a meter. And basically, you have those sights on, and which will give you general idea, general indication of which has basically sensors installed in them. It will share what is the air density. It will share what is the airflow, which direction it is moving, stuff like that. It will give you indication. From that, you will have a better understanding of the overall environment you are firing in. and accordingly you'll be able to adjust the trajectory and yeah, but it actually takes it actually involves practice, and that's why that's about it. Depends on the quality and the quantity of gunpowder used. So the quantity of gunpowder is kind of depends on the kind of gun you're using. So it actually depends on the kind of range you are firing at. So everything comes down to comes down to the range, operating range you are having. So if you are firing in 1,000 yards, like let's suppose 1,000 meters, for that you will have a longer caliber bullet which has more gunpowder in it, and as we saw, as compared to the your normal gun, it has like a smaller caliber bullets where it has a very small portion of it has the gunpowder. So yeah, it depends on the bullet speed does depend on the amount of gunpowder used, but it is highly calibrated while with the kind of range you're firing at. So if you speak about the sniper rifle, so yeah, in that case it does matter what quality quantity of gunpowder is being used. Quantity not as such, because quantity is initially calibrated in order to give you the optimum range. So yeah. Why the shotguns have different bullet model? Um, because because of their operations. Because you're launching at max 5 projectile at a time. So you need to give the barrel. Actually, the bullets should have, and this bullet has this kind of shape due to it has to travel longer stages, longer ranges. And when you have a range, when your range is limited, that's why shotguns have limited range. When your range is limited, you can get creative with the shapes, and you can get creative with the you can actually kind of you can try to have near transonic speeds to your bullets by adjusting the shape of it. So in order to have it in order to optimize it in different way. So there will be drag, no issues. There will be drag, but that drag is expected in certain applications. So for sniper, there is a longer range you need to have. So you need to take into account critically the critical factor then becomes drag. But in pistols have short range, the shotguns have short range, small range. So in that case, you don't need to worry about the drag. So that much. So it's not a pivotal point. Even though it's a very important factor, it is not heavily focused upon while considering the bullet dynamics or its construction, etc. Or its shape, basically. Maximum speed of a bullet achieved as far now. Okay. Yeah, I haven't looked into that yet. But from the looks of it, I generally have it like around the video that I was showing you. It has around the maximum speed of 1450 feet per second, I think. So I actually need to do the conversion, but yeah, it's around 1450 feet per second. So it can reach that maximum stage. So I'll just do a quick conversion for you. It's around 441 meters per second. So that's also goes into the that also goes into supersonic range. I think it's speed of sound is around 340 meters per second. So yeah. Can hypersonic speed be achieved? In the case of bullets, at the moment, I don't think so. Hypersonic speeds can be achieved. But we will talk about hypersonics in our next session in detail, what it is, where it is basically used, how it is achieved. How a civilian can study about bullets, rifles, and guns without going in defense or politics field. Police field, okay, police field. I think there is ballistics engineering. I'm not sure about what its status is in India, but yeah, I think there are specific colleges who provide this kind of engineering, which requires in order to understand, in order to apply. But yeah, that's about it. I have a brief understanding of. I would do a bit of research in that regard if it requires. In the next session, I'll try to talk about it. But yeah, what is the principal work on laser guns? Yeah, actually, I'm not sure about laser guns, Siva. Ashutosh, yeah. So that's about it. I'll quickly go through. I'll quickly take you through a small tour of our website. Okay. So in order to show you what we have in terms of these concepts, because these are just concepts at the end of the day. You don't have a practical understanding of it. So you don't have how it is going to work in real time, how it is going to work in detail. So I'll just talk about the kind of programs we have. Basically, you have different programs in different domains. Accordingly, the domain that you are looking for, you will also get this, not even this, just in-depth understanding of how it is works, like the physics math behind it, how you can visualize it using computational fluid dynamics. So CFD is what one person asked about and out about CFD, how to do a CFD of a bullet, right? So even the video, one of the videos that I've shown you, we talked about velocity field, talked about pressure field. What are those signifies? What are the color coding signifies? How you can actually simulate using a virtual background. You will have a better understanding using this program. In actual understanding, you will have a better understanding of different aspects along with CAE. No, not CAE, CFD, just design aspects of it. You will work on different projects like design projects, for instances. Then you will work on CAE projects, which will cover this kind of analysis. Will tell you the velocity, the pressure, different properties, how they behave, according to which how initial analysis has been done, or initial predictions basically to be done while designing a prototype, anything like that. So this is the general idea about our website. Also, you can click or ask an expert to book a free counseling. Even the free counseling will be provided in the Google form that I'm going to share over here. So you will also have, if you use this coupon code which is mentioned in the chat, this is Super15, you will get a 20% discount on any of the programs that we have. So whatever program that you would want to basically you would want to apply for, you will get a better discount, better understanding of. Even in that counseling, it's not just like a course selling thing. It's like if you have difficulty, as I think Pranjal Rajput, right? Pranjal Rajput has this difficulty of what kind of opportunities are there in ballistics field? What kind of opportunities are there in different fields? How we can get a particular job, or what are the career opportunities? How could I excel in a particular field? If you want that level of clarity as well, you can come to the session. It's no problem. You'll absolutely get the counseling in that regard for free as well. So just fill up this certification form and get an understanding of what sort of requirement you have, where you want to head in career, and accordingly you will get better understanding of things. So yeah, that's about it. I think let me address the people who raise their hands. Vikas Sharma is there, R. Chandra Kumar, and Megharaj. So if anybody of you are online, please unmute yourself, starting with Vikas. If you have any question to share with me or any opinion.
No, sir.
Okay, got it.
सर ये सर्टिफिकेट लिंक से मिलेगा?
Yeah.
Okay, sir.
Okay. So there is also a website link is also pinned. You can go through this curriculum, anything you want to, if you want to pursue in any kind of domain that we have program in, you can check them out yourself. You can click on ask an expert if you want. So all these things are there. Cannot fill the form. Okay, let me check once. So yeah, there are some of the fields that are compulsory. So you need to mention something or the other thing while filling up the form and then submit the form. So is it because I tried opening the form? So yeah, it is working fine.
I will take a course support you mentioned.
Yeah, great. Great. So yeah, I'll be here for a couple of minutes. If anybody has any question, any more questions, anybody want to share something about this interesting topic, you can share. Or if you want anything specific to this field, I can actually try to have something based on that. So to tell you about this, basically those who are watching on YouTube also, they will have this link in the description. And also, if you have participated, there will be a continuation of this. In the next week, I'll talk about hypersonic propulsion of ramjets. So it's kind of a turbo engine, which which makes the flow hypersonic. I'll talk about it, how it makes it hypersonic.